The first presentation will be given by Jay Park, who's CTO of Icon Foundation, and he'll give a talk on their Loopchain, multi-channel smart contract support blockchain. So please welcome Jay with big hands.
Hello, everyone. How about the morning session and lunchtime? Let me introduce myself. My name is Jay Park, and I am a chief architect who leads the Icon project. I am honored to be invited to the IEEE blockchain conference. In this section, I would like to introduce the multi-channel smart contract support blockchain, especially Icon project. This session consists of 4 sections: blockchain, loopchain, multi-channel, and challenges. Before diving into the multi-channel technology, let's take a few basic blockchain concepts. Life cycle of a transaction is as follows. Human or IoT device requests a transaction to one node of a blockchain. Then that node broadcasts transaction all the neighborhood nodes. Each node validates a transaction and approval. After that, a block is created. Verified transactions are combined to create a new block. Finally, a newly created block is added to the existing blockchain. It is permanent and immutable process. So, after the blockchain expansion, no one can alter the contents of block nor the transactions in a block. Transaction is completed. But I left one missing puzzle. It is smart contract. Smart contract is a digitized business algorithm, and once transformed to a programming language, it can be automatically executed without any human interference to meet a prepared condition. In traditional computing environment, programmers use SQL to describe a business logic. But in the blockchain world, using smart contract, developer can program and deploy a business logic into a serverless environment. Smart contract consists of 3 parts. One is agreement. The other is trigger and execution and consensus. After the specific contract agreed by both parties is met, digitized business logic will be automatically triggered and executed without any human interference. And if the result of execution is the same, finalize the result of execution of a contract through consensus between both parties. more trust and low cost is very important. Because of eliminating middleman, the cost is lower. DF, decentralized application, requires both on-chain and off-chain and side-chain. Web or app or legal system communicate blockchain to accomplish its business purpose. For example, a user send asset to the other user using wallet application. And wallet application make a transaction and send to blockchain. The core engine of blockchain consists of three parts: cryptocurrencies part, and token part, and smart contract part. Smart contract use off-chain service and side-chain service. Later, I explain the side-chain features to improve the benefits of blockchain. As already mentioned, Loopchain is the core blockchain engine of the ICON project. I'll present a basic explanation of Loopchain for your understanding. The title is Loopchain as a distributed ledger, but it is a very special distributed database because not only high availability, but also fault-tolerant features is very important. Loopchain here consists of two parts. One is ledger, the other is a database. And counterfeit proof of transaction and block is accomplished using blockchain consensus and blockchain creation and blockchain expansion. And the speed up. It's the unique feature of Loopchain. Finalization of a block requires only one confirm because Loopchain uses default mechanism. The name of Loopchain smart contract is SCORE, smart contract on reliable environment. And its self-development smart contract for complex service scenarios. For example, issue certificate in a blockchain without CA. Copia use the Loopchain as its certification service. Loopchain here consists of SCORE container and SCORE storage and SCORE local repository. Once SCORE is deployed to all the peers, the SCORE is sent SCORE local repository, then ready to execute. Separate blockchain core and container runtime for stability. and instead of a virtual machine, support native execution for performance. But we plan to develop VM versions too. Loopchain overall architecture is as follows. Administrator area and business operation area. In the administration area, operate manage the health of all the nodes. Radio station manage membership of node in this stage. But this is replaced with the decentralized service and APM, application performance management system, collect log data from the nodes and visualization the overall status of all the nodes. And business area, the node is very important because it is the core of blockchain service. Node consists of network engine and consensus engine and score engine. Legal system may communicate with node via proxy. It is very important the node is all the homogeneous components, ease of administration and operation. Loopchain data flow diagram is as follows. A user use the application to issue transaction to a node, or user may use web browser or client program to issue transaction via legal system. For example, web application server. Once TX is issued, a node broadcast transaction to neighbor node, and leader node create a temporary block. Read execute score to temporary result and broadcast block and the result of score to validation nodes. Validation nodes execute score and compare the result of score and voting. If two-thirds of validation node are okay, then the block is finalized. The block is recorded in the ledger, and the result of executing score is written into the state DB. And business logic query the state of smart contract execution and get a result to accomplish a business purpose. We examined the basic of blockchain and Loopchain until now. It's a time to introduce multi-channel feature of Loopchain, and it is the main topic of this session. Bottleneck of blockchain performance is 2 points. If there are too many transactions, it occurs consensus overhead. And smart contract execution overhead. TPS is very important, transaction per second. For example, the average TPS of Visa network is 22,000. But Ethereum or Bitcoin, the TPS of Ethereum or Bitcoin is very low. The target performance of Loopchain is 1,000. But we need more throughput because the more user, the more bandwidth is needed. So we have to devise a solution. First and quick solution is scale-up. That is vertical scaling. We maintain fewer and larger server, and if we need more bandwidth or throughput, add more CPUs, RAMs, and hard disk drivers in one server to accomplish user needs. But there is another option. That is scale-out or horizontal scaling. We maintain more smaller servers and add more servers to the server farm if there needs a more bandwidth or throughput. And scale out in the software. Currently, the execution of a smart contract is serialized. That is, execute one by one, because racial condition means double spent problems. So we have to devise more elegant solutions. Execute group by group. The execution of a smart contract can be parallelized. So, multi-channel can solve these problems. I will explain later. I explained 2 examples of the Ethereum world. First is Raiden Network. Raiden Network is off-chain scaling solution for performing ERC20 token transfers on the Ethereum. It is like Bitcoin's Lightning Network. Low fee, scalable, privacy-preserving payment is accomplished using Raiden Network. There are some advantages. First, speed. No consensus, no confirmation. so it is very fast. And low fee, especially a few dollars or even a cent will be transferred to others because fee is very low. And the stability, linear scaling with number of users. Finally, privacy. It is executed on the off-chain, so private transfer is possible, but it has some disadvantages. First, during the lifetime of the payment channel, user tokens are locked up. And Raiden Network applies only token, but we need a smart contract. To solve this problem, Ethereum developers make a concept, Plasma. Plasma is off-chain scaling solution for performing fast smart contract on the Ethereum. It is like Bitcoin's Segwit, and it eliminates unnecessary data in smart contracts. The idea is very simple. Child blockchain are attached to the main block, and large portion of smart contract execution in the child blockchain. It has some advantages. First, speed. Delegation of complex operations to children, and low fee. Only small block producers are needed, and low resource. Eliminate unnecessary data to save CPU power and storage. Finally, scalability. Distribution of data storage, but it has its own disadvantages. Too many exit transactions. Hard pressure on the main blockchain to process enormous final transactions from child blockchains. So this is the bottleneck. How to solve these problems? It is another good solution. It's sharding. And sharding is horizontal partition of data. Transaction data are divided and distributed into multiple servers. And the total number of transaction data per storage is reduced. Performance and scalability aspect, the sharding technology is very promising. But two considerations. First is sharding rule. Second is rebalancing. It is its own topic. So I skip every details. Multi-channel of Loopchain is virtual blockchain system. Transaction, consensus, and smart contract execution for different business purposes. Single peer, multi-blockchain. And it makes easier development. Isolation per channel, so access control is more secure. ICX is the base coin for icon. All the score depends on ICX. So introduce not multi-channel, but shard. ICX follows sharding rule, and score follows multi-channel rule. So one df of score use an address of ICX, then other dfs use the same ICX address, have to wait until updating ends. Each score state is independent of each other, so introduce multi-channel. Routing mechanism. Address transaction using a dynamic routing table to find out the target channel. So a user issue a transaction to specific address, then look up the routing table to find out specific channel. So the performance of Loopchain is TPS multiplied by number of channel. Job partitioning to leverage the modern multi-core architecture, especially CPU-bound task. Smart contract execution will be parallelized using multi-channel feature. As explained so far, multi-channel is a very simple and powerful mechanism for high performance. But is there any problem? To accomplish the independence, each channel is isolated from others. So we have to devise the communication method between channels. I will wrap up this session with the interchain feature of the ICON project. Blockchain transfer protocol is interchain protocol between Nexus and other blockchain. Notary channel is based on the multi-channel service. Transaction issued by transmitter blockchain is transferred to receiver blockchain via notary channel. And the Nexus check the agreed transaction via right client connected to the Nexus. So blockchain B sent asset to blockchain A, or blockchain B can call the smart contract of blockchain A. But there is no pre-launch. The disadvantage of advantages in multi-channel. Question: what if dep A calls dep C? Answer: access denied, because each score is fully isolated from each other. The solution is interchain. df A on the score channel 1 use interchain to communicate df C on the score channel 2. This is my final presentation. But there is a difficult problem to solve. Smart contract calling between blockchains or channels. How about query function to request a state? It is not, there is not easy solution because query is not transaction. The answer of quiz. Translate the smart contract call into the transaction and vice versa. The every details of interchain process are under standardization. Key takeaways is like this. ICON project tries to solve practical problems related to the blockchain, especially bandwidth and throughput. Please join us to hyperconnect the world. Thank you for your attention, and thank you for your interest about ICON project. Please enjoy remaining sessions and exhibitions. Thank you.
Thank you. Thank you very much. We have time for maybe one or two questions from the audience. Yes. Microphone, please. Here.
Good to see you personally. I have a question. It seems to me it's very similar to Hyperledger fabric. How do you differentiates hyperledger fabric to your icon project? And then what did you do for improved performance?
The major difference between Hyperledger and icon project is the basic architecture. Hyperledger use icon use, as I explained, array. The component of icon is homogeneous, but the hyperledger is heterogeneous. For example, hyperledger uses zookeeper and other open source component to make a data bus, but the component, each node of icon works in autonomous systems. So administration and operation is very easy than Hyperledger, I think.
Okay, I think the second question was on the performance. How did you improve the performance?
As the performance, I can use the multi-channel and as I already mentioned, TPS multiplied by number of channels, we enlarge the throughput and performance.
Okay. Since we ran out of time, I'm sure Joe will stay around. If you have any questions, you can talk to him offline. Thank you, Jae-ho.
Thank you.
Our next